If you're dealing with weak water flow and you believe the solution is simply installing a pump, you're not alone. But here's the thing. If the problem were truly a lack of pumping power, the water would feel weak all the time, right from the moment you turn it on, no matter what else is being used. And that's usually not what people are experiencing. In most homes, nothing is actually broken. There are no leaks, no warning signs, no failed components, everything still works. But you start noticing the water feels weaker when another fixture is being used, or when several things run at the same time. And just as important, it doesn't behave like a true failure. It doesn't feel weak immediately, it doesn't feel weak constantly, and it often recovers when demand drops. At this point, most people jump to the same conclusions. They assume the pump isn't strong enough, a bigger pump will fix it, or a booster pump is the answer. Even many professionals say this. And honestly, it sounds reasonable, because when water feels weak, we naturally assume it's a power problem. But in most real homes, that assumptions miss what's actually happening. In this video, I want to show you two things. First, when a pump actually makes sense. And second, when installing one only wastes money. No hype, no scare tactics, just how the system really works. Every system in a house, water, electrical, HVAC, works as a shared system. Components don't operate in isolations. They share the same source, and they move through the same pathways. So when one part of a system draws more, other parts have to share what's left. That's not a defect, that's normal system behavior. Here's the key principle. A pump can only move as much water as the system allows to flow. So when a system is operating below its limit, you don't notice anything. But when demand increases and multiple fixtures are used at the same time, the system begins to reach its limit. And that limit is not always set by the pump. Let's think this through logically. If the pump were truly too weak, the water would feel weak all the time, immediately, regardless of how many fixtures are running. But what you're actually seeing is different. The water feels fine when used alone, it feels weaker when demand increases, and it recovers when demand drops. That difference matters, because power problems create constant symptoms. Capacity limits create conditional symptoms, and those two things are fundamentally different. Here's the important part. There are situations where a pump makes sense. A pump is useful when the source pressure itself is weak. For example, water supply from a low source tank, a shallow well, or very low city water pressures coming into the house. In these cases, the internal plumbing isn't a problem. The pipes are sized correctly. The layout is reasonable. The system itself is fine. It's simply not receiving enough pressure at the source. In these situations, the pump's job is very specific. It's not there to make the water feel powerful. It's there to bring the water back to a normal, usable level. Once that happens, the water no longer feels weak like before. The system becomes more consistent. Daily use feels normal again. But even with a pump, there is still a limit. A pump doesn't change pipe size. It doesn't change system design. It doesn't change how much flow the system can physically carry. What it does is help the system reach its design limit more reliably, not exceed it. If a system has long runs of small pipe, too many fixtures sharing one branch, poor layout or low distributions, then adding a pump won't solve the root issues. It may increase pressure in one area, while other areas still feel weak. And in some cases, it actually makes the system louder, harsher, and less stable. That's not a pump failure. That's a design limitations being exposed. This situation doesn't behave like a broken system. It behaves like a system operating exactly within its intended limit. Nothing is wrong, nothing is failing. The system is simply doing what it was designed to do. The important thing isn't rushing to install a pump or chasing stronger pressures. It's understanding the system before spending money trying to fix it. Because when a problem only appears under certain conditions, the cause is usually not something broken, but a system that has reached its design limit.